Okay, we continue working on your homework and we simplify surds, but this time we will be adding and subtracting surds and also simplifying them. So what we need to remember, okay? So we can simplify expressions containing surds by collecting like terms. So what that basically means, if we have surds like this, 2 roots of 3 plus 3 roots of 3, altogether we have 5 roots of 3. Okay, we collect in like terms. If you look at the question D, 2 roots of 3 plus 3 roots of 7, these surds, they are different. It's like different units. You can't add them like you can't add, say, 2a and 3b. Okay, they are numbers that you don't know, you can't add them, you can't say it is 5 roots of whatever, 10 whatever, no please fantasies, okay, because if we add surds, we can't really add the numbers which are inside of these surds. You can check on your calculators what is square root of 3, what is square root of 7, add those two numbers together, and also do this, square root of 10, and see that they are not the same. They are not the same. That usually it never will work. Okay? So in general, adding A and adding B is never equal, or not never, but there are some numbers when it just works by magic. You can find which numbers those are, but usually square root of a plus root of b is not equal to root of a plus b, okay? And that's what you need to remember. Okay, so what we have here, let's check. We have question A, where you have 2 roots of 3 plus 3 roots of 3. You don't really need to do any like this, because actually you're just wasting your time. Really, yes, indeed 1 is a perfect square, but once it's taken out of square root of 1 is just simply multiplying by 1, and as you notice at this line, after two lines of working and spending your time, actually what you came to is the same as you had before, which is 5 roots of 3. So you could go straight to this with no workings out needs. That's your workings out for this case, okay? Let's see the next question. So 7 roots of 7 minus 3 roots of 7. You don't need to do any of this, because as you see, after all these calculations you came to the same position where you started from. What you did realize, though, which is great, that 7 roots of 7 minus 3 roots of 7 is 4 roots of 7. It's like 7 apples minus 3 apples is equal to 4 apples. So you have 7 things minus 3 things equal 4 things. So the same with surds, okay? You applying the same rules as with collecting like terms. So all of that again wasn't necessary. 7 roots of 5 minus 3 roots of 5 is 4 roots of 5. As you see, this expression that you worked very hard to get to is the same as where you started from, okay? So this one, absolutely no need. Again, you see there are different units, so you don't add them, you just leave it as it is, okay? So 2 roots of 7 minus 3 roots of 7. So 2 things minus 3 things will be minus 1, okay? 2 minus 3 is actually minus 1. So you have minus 1. I can't see minus here, so that is then wrong answer, okay? But what I would like to say, although we've got minus 1 times root of 7, we are not writing 1 next to any surd. For example, we are not writing 1 times root of 7. Root of 7 is just root of 7, okay? As in algebra, we're not writing 1 times a. We just simply write a. Okay, so you don't need to do this. So the answer is minus root of 7. End of story. Okay, now here we have now a different situation. We have 2 roots of 32 plus 3 roots of 2. Okay, we need first to simplify. I disagree with this simplification. As you see, we have 4 times 8. Again, you split it up, all of this. You use calculator definitely, and you imagine you can't use calculator because it's non-calculator exam. And what are you going to do? You could split up as you did, but don't forget to check every surd that you received whether it can be simplified any further. And as far as I can see, square root of 8 can be definitely simplified any further. You don't need to split any surd into surd times root of 1, because square root of 1 is just 1, and multiplying by 1 doesn't make you any good. It's just simply the same as you had. So what I'm trying to say, you still need to simplify, and perhaps square root of 32 is the first candidate. All right, so let's simplify it. Again, we will be looking for the highest perfect square as a factor, which is 16. Okay, 16 is such factor, so this one will be square root of 16 times square root of 2. Square root of 16 is 4 times root of 2, so the answer is 4 roots of 2. Now we need to take this root of 32 and multiply by 2. 2, okay, 2 times, instead of root of 32, I will write 4 roots of 2. 4 roots of 2, and plus 3 roots of 2. 2 times 4 is 8 roots of 2, plus 3 roots of 2, okay, which is equal to 11 roots of 2. Yep, done. Okay, now we need to simplify again everything what we can simplify. And if you look at this surd is already simplified. You can't do really anything here, it's just waste of your time. Look at this, and write this square root of 1, which is the same, so you came to the same position where you started from, so don't waste your time there. But this simplification was really good. Square root of 27 is square root of 9 times 3. Square root of 9 is 3, and 3 times 2 is 6. So you've got here 6 roots of 3 minus 3 roots of 3. 6 things minus 3 things will be 3 things, right? So 6 roots of 3 minus 3 roots of 3 will be 3 roots of 3. That's correct answer. Now the next one. Okay. Okay, you tried to factorize each expression here and to see what happens, and as far as I see, you realize that square root of 24, although it can be split in this manner, you can do something with maybe with these numbers, but you could not do much with root of 3 times root of 2. It's because root of 6 is already simplified. You're really not achieving much here. So therefore let's look at the square root of 24. Alright, square root of 24 has 4 as a factor, which can go out of square root, and square root of 4 is 2 times square root of 6 is 2 roots of 6. Now we have square root of 24 is 2 roots of 6. 3 times 2 roots of 6 is 6 roots of 6, because 3 times 2 is 6. So we have 6 minus 3 roots of 6, and the answer is again 6 minus 3 is 3 roots of 6. That's the answer, and that's the answer obviously here. 5 roots of 7 plus 3 roots of 28. Again, no need to do all of this, because you really didn't achieve anything. You see, after taking out root of 1 out of surd, right? So you literally, it's nothing, because you were actually multiplying by 1. So you see, you had 5 roots of 7, and you still have 5 roots of 7. So that was a little bit a waste of time. So let's leave it as it is, but let's look at square root of 28. This was really good, because square root of 28 was written as 4 times 7, and then square root of 4 and square root of 7 was taken, and square root of 4 is 2, so 3 times 2 is 6, so this is 6 roots of 7. And now what we have 5 roots of 7 plus 6 roots of 7. Altogether it is 11 roots of 7. Okay, right, here we have more complicated expressions, which were split into factors of prime factor and another factor. Okay, so 125 is indeed 25 times 5, and here I wouldn't say so, right? I wouldn't start working on 80 this way. Look, square root of 80, look for the highest possible square number as a factor. 80 is 16 times 5, okay? And this is square root of 16 times square root of 5. Square root of 16 is 4. 4 times root of 5 is 4 roots of 5. Now we need to go back to this expression and to simplify. Okay, you could also, to be honest, work separately on square root of 25, simplify it. Okay, this is square root of 25 times square root of 5, which is, this is 5 times roots of 5. Okay, now let's replace our square root of 125 with 5 roots of 5. When you're replacing them, don't forget to multiply by 2. 2 times this, which is this. So 2 times 5, 10 roots of 5, okay? Minus, and now we have 3 times this. But square root of 80 is 4 roots of 5, so 3 times 4 is 12 roots of 5. So now what is 10 minus 12? Minus 2 roots of 5, and that's the answer. Here, this answer is wrong. It has to be negative 2 roots of 5. You see, 10 minus 12 is negative. Okay, here we are. We have another question. We have 108 as a square root. As you see, it was simplified. Again, here we understand, but not quite, because 108 is 36 times, okay, if it would be 4, it's too much, so it will be 3, right? 36 times 3 is indeed 108, and this is square root of 36 times square root of 3. Square root of 36 is 6 roots of 3. Okay, now we'll have 300. 300 is 3 times 100, and 100 goes out of root is 10 times root of 3. Now we're ready to add them together. So we have 108 under square root plus 2 roots of 300, which is root of 108 is 6 roots of 3, plus 2 times root of 300, which is 10 roots of 3. So we have 6 roots of 3 plus 20 roots of 3, which is 26 roots of 3. That's correct answer, must be achieved without using calculator. Okay, and final question. Because I can't see clearly every step of these calculations, I would like to do them step by step. So we have question 5 times 294 under square root minus 3 times root of 216. So we'll pick up every square root and we'll simplify it. 294 is divisible by 7. Okay, if we divide by 7, we are getting 29 divided by 7 is 4, and 4 times 7 is 28, the remainder is 1, and 14 divided by 7 is 2, and 42 is 7, and this one is 6. I don't want even carry on because I already see where my perfect square is. 7 times 7 times 6 makes 294, but 7 times 7 is 49, right, times 6, so this is 49 times root of 6, and square root of 49 is 7 roots of 6. Let's do square root of 216. Okay, 216 is 16 squared. You can no, not 16 squared. Let's check. Let's divide by 2 first. 216 divided by 2 is 108. Yeah, and 108 was just done recently. 108 was 36 times 3. So we have 216 as 36 times 2 times 3, which is 6. Okay, square root of 36 times root of 6 will be 6 roots of 6. Now let's go back to our expression here. 5 or we can carry on like this, okay? 5 times square root of 294, which is 7 roots of 6, minus 3 times root of 216, which is 6 roots of 6. Okay, what is 5 times 7? 35 roots of 6. What is 3 times 6? 18 roots of 6. What is 35 minus 18? Okay, minus 20 is 15, plus 2, 17 roots of 6. That's it. That's the final answer. Don't use calculator, and I hope it helped you with the homework. Thank you for working very hard, and thank you for watching this video.